Hello, everyone. Welcome to Evolving a Legacy System with Architecture for Flow. And I start with a question to you. So who of you, hands up, has to deal with legacy system that evolved over a long time on a regular basis, like on a day-to-day work, and that has evolved and become monolithic, big ball of mud, and a lot of discussions are coming up, great. And to follow with the next question to you is, to who of you does your legacy system spark joy? Oh, we have here 2 hands up. Oh, I would love to talk to you later on. So yeah, to ask it in the way Marie Kondo puts it, the organizational expert tidying up your home, like, does your legacy system spark joy? And usually that's the main answer usually is, no, it does not spark joy. And when we describe legacy systems, usually negatively connotated attributes come to our mind. Like, it's difficult to maintain, it lacks modularity, its architecture is tightly coupled, it's hard to test or lack adequate test coverage, and it's slow to adapt to new and changing circumstances, it's expensive to maintain and accumulate a lot of innovation constraints. So the paradox is that the paradox of our legacy system is that, on the other hand, they also represent past success. So, and they contain, I'm sorry, is the tone not good? So on the other hand, they contain years of accumulated domain knowledge, and they are battle tested, and they are stabilized over the years, and they survived years of production use and even decades of production use, and they are still standing. So they are also often deeply integrated in our today's workflows and processes that a lot of teams rely on every day. So they represent proven business value, and that made the company successful and even also paid our salaries. I'm not sure how to fix it. Is it bothering? Okay. So we shouldn't just curse them, but we also should respect them. And as Marie Kondo usually says, phrase them as thanking them for the service. But she also compliments them, thanking them for the service. Okay, is it better? Thank you so much. Okay, I continue. So usually says them, thank them for the service and let them go, discard them with gratitude. But discarding a legacy system with gratitude, that is not so easy with large, heavily integrated big ball of mud that has evolved over the years, than discarding a piece of clothes or a book or something like that. So discarding a legacy system in a big bang approach is usually very expensive, and not just expensive, but also very risky. So instead, we need to follow a more evolutionary approach and an incremental evolution as a safer path. So when evolving legacy systems, we also have to consider that systems are composed of interdependent subsystems. And organizations in general, they are typically composed of not only technical aspects, but also social aspects that cannot be treated separately. And instead, they need to be aligned in order to become adaptive to new and changing circumstances. And when we want to evolve a legacy system to become an adaptive socio-technical system that is optimized for a fast flow of sustainable value and constant feedback, we also need to implement, or we need to apply a holistic approach that combines multiple perspectives. And one holistic approach that I would like to share with you today is combining patterns and principles and practices from wordle mapping, domain-driven design, and team topologies, which in short is phrased as architecture for flow. So how to bring these perspectives together? I know you can't read it, by the way, that's on purpose, but I also provide, by the way, a link to my slide deck at the end of the presentation as well. So how to bring these perspectives together? And I developed an opinionated, structured approach, visualize an architecture for flow canvas. And this architecture for flow canvas that helps to assess our current status quo, where are we right now, where is the situation, and guides us, facilitating then designing the ideal future, our to-be situation. And the canvas itself is not a rigid framework. Instead, it provides as little structure as possible and allows to be complemented with other techniques as well. So, and also depending on the context, the sequence might change, or you can skip some steps. So it is an iterative, continuous approach, and we do not want to end up with a large upfront design. Instead, we want to have as little design as possible so that we get a direction, an informed direction to move forward. And it typically begins with the teams of today and then ends with envisioning the teams of tomorrow. So starting with the teams of today, typically involves analyzing the current teams in terms of like the current team structure, what teams do exist, including their team sizes and their way of working. How do the teams depend on each other? What is their way of interacting with other teams? And what parts of the system do they own? So what are their responsibilities? And these insights can then be used later on when we go into the incremental evolution as a starting point. I make dramatic pauses because so coming from the team overview, the next step is then to assess the current flow of change. And in an ideal case, teams shall fully own the entire end-to-end flow from generating our first ideas to delivering value to our customers with minimal impediments and with minimal blockers to flow along the way. And teams often know what slows down their work. So meeting teams where they are and asking them, so what currently blocks your flow of work, that helps us to identify the impediments that we want to mitigate. But also not only the blocker, but also the elements that works well in our flow is also worth to be collected during those interviews, because that are the elements that we would like to keep. That's the elements that we would like to preserve. And those pain points that we are collecting could be revisited later in order to identify which of those blockers we could mitigate, or which of those blockers still might need some attention, or even if new blockers might emerge that we have not seen before. And so that is kind of like a continuous feedback loop involved. So when analyzing blockers to flow, that can be done from various perspectives. So if teams do not fully own the entire end-to-end flow from designing, developing, testing, releasing, deploying, operating their parts of the system they are responsible for, then they depend on other teams' tasks and activities to get our work done. So we have to hand over work to them, and we have to wait until they complete the works and until we can then progress with our own work. And handover, or specifically repeated handover, that requires a high amount of communication and coordination efforts, and introducing wait times, slowing down our flow of change. And if teams are missing capabilities and need to bring in people with a specific expertise in order that they do something so that we can progress and continue with our work, that can also affect our flow of work, specifically when the people we depend on are not available when we need them. And every blocking dependency requires some level of communication and coordination efforts, and increases also the probability of waiting time and delays. Particularly when the people we depend on are not available, or when the teams we depend on are so overloaded that they can't keep up with the demands placed on them, so they become constraints and slowing down the overall system's performance. So if teams have to interact with many other teams in order to get their own work done, then that could potentially slow down our flow of change. And from a software architecture point of view, with tight change coupling, it also affects our flow of change, as changes in one part of the system might have unpredictable side effects on other parts of the system, and also introducing defects and rework when we want to change something. And from a software architecture of software quality perspective, technical debt such as poorly written code or lack of adequate test coverage, pattern violation, code complexity, that leads to fragile code bases that are pretty difficult to maintain long term. And a messy architecture with fuzzy boundaries that make it pretty difficult to establish clear ownership boundaries. And that could lead to a lack of clear ownership, which in fact then decreases accountability and also introduce like a not my job syndrome, and can cause decision delays and also impede our flow of change. And when teams own too many or too large parts of the system, their team's cognitive load can exceed. And when a team's cognitive load is largely exceeded, it can also become a delivery bottleneck. And when teams lack priorities and focus, they often try to work on multiple tasks, resulting in a higher work in progress, and jumping between tasks back and forth without completing them. And with frequent interruptions and unplanned work, for example, coming with like doing a lot of like defects or fixing a lot of defects, and that also leads then to a lot of context switches affecting our flow of change as well. So to who of you does those blocker to flow look familiar in your cases? So usually when I do this run through, that everyone asks me, so have you listened to our conversation in the organization? So a few hands are up. So you are not alone, by the way. So after we have addressed the current teams and their blockers to flow, now we are now progressing to understand our current business landscape. And mapping the current business landscape usually starts from the user perspective. Clayton Christensen, the inventor of the Jobs to be Done series, stated that people buy products and services in order to get a job done. And in order to help users to get a job done, we need to know who our users are and what jobs they want to accomplish. And we also need to identify what are the desired outcomes as the user needs that the users want to achieve when they want to get a job done. So in an example of an online school solution for junior students, one of the user types can be the teachers, and their core functional job is facilitating remote learning. And to accomplish this job, the teachers need to prepare learning material, they need to assess the student understanding with assignments, they need to track the student's progress over time, they also need to facilitate communication or communicate with the students back and forth, and they also need to ensure and set up a secure access to the learning platform, for example, through sign-up and sign-in processes. So in the jobs to be done and the user needs, they are representing the problem space, and they are usually solution agnostic. So they remain the same, however we are going to solve it in the solution space later on. So they don't care if you use the latest AI models, or if we LLM models, or if we use, I don't know, serverless technology underneath, as long as we fulfill the user needs efficiently and effectively. So in the solution space, those user needs are then directly or indirectly fulfilled by a chain of components that generates value by fulfilling those user needs. And that's where we can blend in the value chain. That's the y-axis of a Wortley map, where the users and the user needs are representing the anchor of the map. And the value chain itself that shows how different components connect to generate value that is aligned to the user needs, and visualizes also the components' dependencies. And we can start with just a few components first and can iterate later on. And the components of our value chain are then typically mapped to evolution stages on the x-axis from such as Genesis with brand new things on the left side of the evolution axis, then custom build, then product and rental, and then commodity and utility at the right end of the spectrum to addressing the evolution stages. And creating a map usually is then, that's something that's an exercise we do within a group in order to gain a common understanding of our business landscape in which an organization is operating and competing in. And it helps us to challenge also our own assumptions. So the map itself helps, during conversation, helps to assess efficiency gaps, for example, address questions, are we custom building components that are not core to our business? For example, as Jackie said, shall we custom build our own encryption library? Definitely we should not, unless we are in cybersecurity and that is our core domain. And so the map helps us to identify areas where to invest and innovate and what to involve and outsource in order to gain competitive advantage. And I personally use the Worldly map as a visualization tool that guides through an optimization process. So coming from the as-is situation with our current teams, with the pain points, with the current business landscape we are operating and competing in, now we are gradually blending over to the to-be situation, our ideal future. And that's where we are categorizing the problem space. And categorizing the problem space bridges the status quo with our ideal future or to-be situation. And the user and the user needs, they are not only representing the anchor of the map, but they are also representing the problem space and the problem domain. And that's where we can blend in domain-driven design. And domain-driven design helps us to gain a shared understanding of our problem domain and helps us also to partition our problem domain into smaller parts and subdomains. But subdomains are not all equal in terms of, or not equally valuable to the business in terms of differentiation. So some are more valuable to the business than others. So we have different types of subdomains. For example, the core domain, that is the essential part of our problem domain providing competitive advantage. So that is the subdomain in which we should strategically invest in most. The supporting subdomains, these are the subdomains that help the core domain's offering. So they provide no competitive advantage, but are necessary for the organization to succeed. And the supporting subdomains are usually prevalent, exist in other competitive solutions as well. So they are non-differentiating, but they are usually highly specialized. And the generic subdomains, that are the subdomains that many business systems have, for example, authentication and registration. So they are not only consistent in our competitive solutions, but across all business solutions. And they do not provide competitive advantage, but businesses cannot work without them. So generic subdomains are neither specialized nor differentiating. So, by categorizing this problem space into the subdomain types, we are getting then an indication where we should focus our major strategic investments, and also supports us then in the solution space where to build, buy, and outsource specific components of our value chain in order to gain a competitive advantage. So after we are blending in now to the ideal future. So we have categorized the problem space into subdomain types of core, generic, and supporting and generic. The next step is to achieve modularity in the solution space. So coming back to the online school example, in the solution space, the subdomains are currently all mingled together in a monolithic big ball of mud with a messy model and no clear modularity boundaries. So which is causing then the blockers like change coupling, lack of clear ownership, team cognitive load, and also an inefficient focus of development effort on also non-differentiating parts of our system and affecting our flow of change and also our efficiency. So unlocking those blockers to flow requires then to architect for change and also leverage the power of small. And that means that we have to move away from a monolithic big ball of mud with messy models and no clear modularity boundaries, and leverage then modularity with high functional cohesion and loose coupling, and which requires to decompose our monolithic big ball of mud into modular components. And that brings us to bounded context of domain-driven design. A bounded context itself helps to group related business behavior together, and it defines where a single domain model can be applied, where a single domain model lives in, that encapsulate specific business logic of a related subdomain. And bounded context also enforces high cohesion and modularity from a business behavior point of view. And they are indicating good domain logic specific themes to split our system apart into smaller modular components and smaller modular well-encapsulated parts. And they also serve very well as team ownership boundaries, and I come back to that one in a minute when we talk about the team perspective. So designing bounded contexts and domain models, that typically involves a close collaboration between domain experts and development teams, and in order to gain a shared understanding of our problem domain. And there are different techniques available that helps us with them. One of them is event storming. That is a lightweight collaborative modeling technique invented by Alberto Brandolini, and which allows us to explore complex business domain by mapping out domain events, things that has happened in our domain along a chronological timeline. So, and I usually start the conversation when I start an event storming session coming from the user needs of our Wardley map and ask questions. So what has happened in our domain when, for example, the teachers would like to prepare learning material, or when they want to assess the students' learning progress, or when they want to track the progress or communicate with the students as well. So that is usually my conversation starter that then funnels into event storming workshop sessions. And during those conversations, during those sessions, we can then gaining insights describing what has happened in the domain with domain events, for example, course outlined or content published, exercise assigned or student enrolled to class, and so that we gain a shared understanding of our domain and also can identify potential candidates for bounded context, our modularity boundaries. For example, content creation bounded context, assessment bounded context, progress tracking, notification handling, and so on. So after categorizing the problem space and in our subdomain types and also modularizing our solution space, the next step is to integrate those and to envision our ideal future on a Wardley map and to visualize our future business landscape. And from a strategic point of view, with modular bounded context now in our solution space, we can now better target our strategic investment and can ask questions: are we custom building parts that do not belong to our core domain, that do not provide competitive advantage? And the previously discovered subdomains and the designed bounded context led us to focus or enables us to focus our major development efforts around our core domain related bounded contexts that provide competitive advantage and building them in-house. And for unspecialized non-differentiators, for example, for the generic subdomain related bounded context, authentication, registration, and so on, that do not provide competitive advantage, but that entail standardized, well-known processes and functionalities. So here we can leverage existing off-the-shelf products that are available in the market. And for the supporting subdomain-related bounded context, the decision whether to build or buy is a little bit more nuanced. So they are non-differentiating, so they don't provide competitive advantage, but they play a significant role in supporting the core domain's offering. So, and they are sometimes very specialized to our domain. In case they are so specialized that there is no product available that we can use, then we might considering to custom build these supporting subdomain related bounded contexts. And whether we could leverage further evolved components is not restricted to our bounded context alone, but it needs to be assessed for our entire value chain. So in our example of the online school solution, we can also ask questions whether we should evolve our currently infrastructure components that runs on on-premises infrastructure ecosystem and evolve them and migrate them, for example, using then cloud-hosted services that are available as commodities and helps us to close efficiency gaps. So, but we also need to be aware that we have to consider the socio-technical aspects. And the next step is then also to address then the future team ownership or future team organization and also align the teams, involve their interaction to the system we build and the strategy we plan. And that requires to optimize our flow of change, and we need to analyze, for that we need first to analyze what will drive value and change in our organization. And that requires to identify where the most important changes in our system occur, the streams of changes. And the user needs of our Wortley map, they represent good customer-driven streams of changes and ensuring a fast flow of change where it matters most. So we have to organize our teams and system around these customer-driven streams of changes. I'm giving up. So deriving the future team organization that involves then finding suitable team boundaries aligned to customer-facing streams of changes. And as stated previously, the bounded context, they serve very well as well-defined ownership boundaries, making them not only good candidates to split our system apart into modular components, but also serve very well as good ownership boundaries for streamlined teams. And streamlined teams, that comes from team topologies. It's one of the team types that they describe, and they are cross-functional, autonomous, small, long-lived teams that are aligned to a continuous flow of work and that focus on a fast flow of changes. In order that they can focus on a fast flow of change, to maintain a fast flow of change, the streamlined teams depend on other teams in order to help them to deliver their own work, for example, such as platform teams. And platform teams, they are responsible for platforms that the streamlined teams can easily consume, and they are very important, optional to use. They are not mandatory, and they can vary in its level of abstraction. So at a lower level, a platform can abstract away, for example, infrastructure, networking, cross-cutting capabilities. At a higher level, a platform can also abstract away a design system, a data platform, and so on. So, and a platform team, they provide internal self-service capabilities and services and tools that the streamlined teams can easily consume. And to provide platform capabilities, we also need to identify services that support a reliable flow of change, and that can be delivered as platforms providing then self-service capabilities. So we can look at our value chain, what components we see as good platform capabilities, as potential platform candidates. By the way, we can also complement it with other Wortley maps as well. So coming from the external customer-facing Wortley map, also complementing it later on with internal team-related Wortley maps, where then the streamlined teams become the users of the services that the platform team will provide. So, but to organize those team into team types is not enough to become effective and efficient, but how the teams interact with each other and when to evolve and change the team interaction is also crucial to optimize for fast flow of change. So a platform team can initially collaborate with one of the streamlined teams for a limited period of time in order to gain insights. How can we support the streamlined teams delivering their work? And also we can revisit the previously collected pain points as well. So, and additionally, also streamlined teams can, of course, collaborate in sharing their insights while they go on a refactoring journey, for example. And if teams lack certain skills, maybe enabling team can engage as internal coaches and help to upskill other teams and help them to acquire missing capabilities. And these interaction modes can evolve over time. And for example, a platform team might initially facilitate other teams using their platform and can later then evolve into XS services where they provide self-service capabilities. So at this stage, the initially identified blockers to flow can be revisited in order to assess which of them have been mitigated, which of them might still require additional attention, or maybe new blockers have emerged. So the architecture for flow approach helps to uncover or unlock a variety of blockers from the software architecture, from the technical, from the team ownership and team dependency perspective as well, and also helps to try to close efficiency gaps. So we got an understanding of our current situation, and we got a first impression on our ideal future. But now the big question is how to transition. So since that we have not moved anything yet. And we would like to avoid definitely the risk and the cost of a big bang transformation. So that requires to move incrementally in small steps. So in this particular example, I just want to highlight that's not a blueprint, it's just like in this example, the incremental evolution is characterized by reteaming the existing teams and replatforming the underlying on-premise infrastructure to cloud-hosted services and refactoring the big ball of mud into modular components. And also is supported by an evolution of team interaction modes along the journey. So the transition can start from the status quo, where the teams are currently organized as functional silo teams in front-end, back-end infrastructure operation teams, and that own a monolithic big ball of mud running on top of an on-premise infrastructure. And the team's flow of change is currently heavily interrupted through handover with all the involved blockers to flow that we have identified earlier on. So the transition could start in this specific context, for example, with maybe a platform team first that kicks off then the replatforming cloud migration journey. And with replatforming, we are incrementally replacing the on-premise infrastructure components to cloud-hosted services while we keep the architecture of the application the same. And to start then, to modernize the monolithic big ball of mud, then the first streamline team can be formed and kicking off then the refactoring journey. And the refactoring journey then focuses on incrementally decomposing the big ball of mud into the previously designed bounded context, and can also, we don't have to deal with like, okay, let's carve out everything as microservices. That's not what I mean. So it can start with a modular monolith first and can evolve gradually depending on its quality attributes, the software architecture characteristics, then demand for a different architecture style. So, and to address applicable cloud options, for example, the Streamline team can then collaborate with the platform team to discover some cloud options that might be applicable for the bounded context the Streamline team is going to be responsible for. This collaboration can then later evolve in XS service. And then also continuing the refactoring journey, then the next Streamline team can form and carving out their corresponding bounded context from the monolithic big ball of mud. And during this refactoring journey, this new Streamline team can be supported by the first form Streamline teams with collaboration or facilitation, where the first team can then also share their refactoring knowledge that they have gained in their journey. And while the platform team then provides self-service capabilities. And then the next teams can be formed, supported by an evolution of interaction modes, and also to reiterate all the insights that they have gained through their journey. can then also be used to course correct our ideal future that we have. That was just our very, very first assumption. So that has to be constantly adjusted. So this evolution process is fundamental, very adaptive, and instead of like a sequential waterfall process, it's more a continuous cycle between discovery and design and an incremental evolution, and where we feeding in feedback loop constantly from our gained insights during our implementation process. So starting with discovery, design, assessing the current as is, designing the ideal future, and then incrementally evolve. And also adjust our initial, our first understanding, also our first assumptions. So to come to the end, the combination of Wardler mapping, domain-driven design, and team topologies helps us to generate a sustainable value aligned to user needs. It helps us to unlock blockers to flow, and it helps us to focus our major development efforts or strategic investments on our differentiators that provide competitive advantage, and also helps us to align our teams and evolve their interactions to the system we build and strategy we plan. And this combination provides a powerful tool set to design, build, and evolve adaptive socio-technical systems that are optimized for fast flow of change and constant feedback. But this is not a silver bullet. I have a disclaimer. So what works, there is no single right way to apply it. So what works in one organization might work differently in another organization. And it's, as I said, it's not a rigid framework. It has to be adapted to your own context and your pain points as well. And to close with Marie Kondo, so we should thank, I would say, our legacy system for the service. But instead of discarding it with disgratitude, we should evolve it with gratitude and to become also a future success as well, or remain a future success. I also collected some resources at the end. And with that, I guess I'm running out of time. I'm sorry for that. I also provided the link to my slide deck if you would like to download it. And with that, I'm thanking you so much for your attendance.